hand these things called exceptions. What are exceptions used for, if you recall, in JavaScript or in other languages? Yeah. Yeah, so they're handling errors, right, in C. And also with a lot of functions in PHP, how do you signify that something bad happened? What do you do normally? If you're a function and you can't give a correct answer because something went wrong, file not found or unreadable, something bad happened, what do you do? So nothing, right? You at least have to return. And if the function has a return type, you have to return some value. And if the function is supposed to return an int, you have to return an int. But the problem that arises in C and in lots of languages is, well, if this function is meant to do math and return a number, well, how am I going to signify an error if 0 might actually be a valid answer or -1 might actually be an actual answer? Now, PHP redressed this by introducing these things called notices and warnings and errors, which even if you never quite understood why your code was triggering warnings and notices and errors, it did mean something bad was happening, but that was sort of a back channel mechanism for the language to say something bad happened in increasing order of severity, notice to warning to error, the first two of which you can ignore, but your code has some issue. Error means fatal error, can't proceed at all. So that's sort of a back channel mechanism, but it's a little messy, right? Almost everyone in this room probably wrote some PHP code, if you took 50, that triggered one or more of these errors. And so it'd be nice if we could catch them more effectively. And so what these things called exceptions allow you to do is exactly that. Rather than just do something by calling a function, you can instead try to do something. And if anything goes wrong that might otherwise impact the correctness of your program, that function can throw an exception, which is a special object, a special structure that you in your code can catch. So this simple example here in JavaScript proposes to do exactly that. If for some reason this special thing called an XML HTTP request object doesn't exist, well, that function call is going to throw an exception. And if I catch it, I can then conclude that, OK, that didn't work. Let me try something else. And in this case, this means if that didn't work, it means you're using Internet Explorer. So we'll try this other mechanism instead. So where else is there now room for improvement? So we introduced jQuery not just for form validation and the like, but also in the context of Ajax. And Ajax is certainly all the rage today. In any dynamic website from Facebook to Google to any number of others, they're using Ajax underneath the hood. And just as a quick refresher, what does it mean if a website uses Ajax? Sure. We'll just have a nice conversation here today.
They can handle requests without having to refresh the page.
Perfect. It can handle HTTP requests, posts, gets, others, without having to reload the whole page. And this allows you to have a much more seamless interface for users rather than having to reload the whole page. So again, think of your Gmail inbox automatically showing new mail, Facebook status updates automatically appearing, all thanks to Ajax. But notice what's interesting here about jQuery and more specifically JavaScript. There's a whole lot of curly braces here. And that's because fundamental to JavaScript, or quite popular within JavaScript, is the use of objects. And an object, really just a struct, but it can have more things than just variables inside of it or properties. But these structures, these objects induced by open curly brace, close curly brace, allow you to pass around arbitrary collections of key value pairs. And so a very famous computer scientist once said if you could only have one data structure on a desert island, it would be a hash table. And that's because these things are so versatile in that you can store arbitrary combinations of data, keys and values, even hierarchically, simply by giving them names and associated values. And so this is hugely compelling in JavaScript. And we saw this in the context of associative arrays in PHP. Well, now let's pick on pset 7, which in CS50 was CS50 Finance, where you had to implement an E-Trade-like website in HTML and in PHP. So here was a snippet of index.php. And when you were implementing, if you implemented that pset, you might recall writing this code again and again. Or frankly, realistically, you probably did cp index.php space whatever the next file was that you wanted to create. So there was a whole lot of redundancy littered throughout your code. And even if you were wise and you used CSS and you factored everything out into a styles.css file, what we didn't really do or preach in 50 was factoring out even common HTML code. In fact, notice we have head, we have body, we have this top div and a logo, we have close body, close HTML. Those were probably common to every one of your pages for that particular project. And what's the downside of having the same code in multiple files, just to be clear? Yeah?
If you ever change it in one instance and you want the change to propagate, you have to change it in every file.
Yeah, exactly. It's as simple as that. Like, it's just annoying, if nothing else. And it's also prone to errors because if you miss just one thing, either aesthetically or functionally, your site's not going to work as intended. And this is why we introduced .css files and .js files, so we could factor that code out. Wouldn't it be nice if we could start to factor out common template code like this in PHP? And indeed we can. So one of the topics of the course will be design patterns, among them MVC, Model View Controller, which is a common technique for doing exactly that, keeping all of your logic, your so-called business logic, and sort of the core intelligence of your program in separate files altogether, and then relegating all of the aesthetic stuff like CSS and HTML to templates or other sort of standalone files. And the upside of this is not only can you make updates across the board for your application in just one single place, you can also do neat things like support a desktop browser and a mobile browser and some other third device simply by changing only those templates, only the HTML, only the CSS, but all of the hard work that you put into the site, all of the true like logic, the database calls and the like, can live independently. And so among the themes of the course will be designing your own APIs and sitting down with your partner and deciding with him or her what methods or what functions you're going to implement so that he or she can assume that those functions will exist when his or her code calls those functions. And so we'll be able to divide work much more effectively when it's no longer just one of you, but multiple folks together. So lastly, in PSET 8, we use the Google Earth and the Google Maps API. And Google's JavaScript libraries are really actually illustrative of some of the more advanced things you can do with JavaScript. So JavaScript allows us to do things like this, where in this first line, this is what we'll eventually call a factory pattern, where you have some kind of special global object, .createPoint, which apparently is creating a new structure called a point. So you could actually do this with other syntax. We used malloc in C, we used the new operator in JavaScript and also PHP, but this is representative of a design pattern that we'll look at, where if you want to create multiple copies of some kind of object, you can relegate that functionality to what we'll call a factory. And here is perhaps a very canonical example of what we'll do in most every one of the languages we use this term. We have a variable here at left in JavaScript. We call the keyword new, which says give me a new chunk of memory, and invoke the following function, in this case a marker function, which is designed to look like what's a constructor? Those of you who took APCS or the like in high school might recall from Java constructors and the like. Well, this is a way of implementing that same idea, but as we'll see in JavaScript, there aren't classes per se, but these things called prototypes. But this too will allow us to discuss some other aspects of that language as well. So without further ado, let me pause for a moment and introduce our two courses heads, Rob Bowden and Tommy McWilliam. If you'd like to come up here and say an awkward hello.
Hi there. So for those of you who don't know me from CS50, my name is Tommy. I just want to emphasize that whether you're coming from CS50 or if you've taken as many CS courses as Rob, that you really have a lot to get out of this course, because really we're focusing on engineering and skills that can really be applied to any of your side projects or any other CS course that you're going to go on to take here. So we certainly hope we see you this semester.
Hi, I'm Rob. I can't tell you all good work quite yet, but if CS50 was any measure where I was just so impressed by all the projects I saw, then I'm sure when we come back here, however many weeks long a semester is, that I'll be able to stand up here again and just tell you how proud I am of all of you.
And then structurally, what's in store for us this semester? So, and you will meet, as an aside, the rest of the team over the course of this week and next. So, topics among which we'll explore this week. So abstraction, encapsulation. So these are the buzzwords, or really the fundamental ideas behind a lot of the language features that we're going to really start to take advantage of and appreciate ultimately. Abstraction being this idea of being able to implement, for instance, a linked list that's not hard-coded for ints, that's not hard-coded for students, but it's just a linked list inside of which you can put any piece of data that you want. And to do that, you encapsulate information. You encapsulate the next pointer. You encapsulate the head of a list, potentially. And so these themes will recur as we start to design software better. So we'll look at these ideas of classes, prototypes, and objects, some of which you've probably seen in AP Computer Science, if that is your background. But we'll look at it in all sorts of contexts, as well as how it's used differently in these various languages. We'll look at more sophisticated, object-oriented techniques. So what is, first, though, this buzzword of OOP, object-oriented programming? It really does boil down to taking structs, to the next level, being able to associate inside of some container not just properties or variables like students' names and IDs and the like, but functionality as well, so that you can build into a linked list or build into an array the searching functionality or the sorting functionality, so that you can build into a student object the give me your first name functionality, give me your initials functionality, so that when you say foo.bar, bar no longer needs to just be a variable, it can actually be a function, otherwise known as a method that you call. So these words really are synonymous. Function is when you're using procedural programming like C, where you have no classes and objects. A method is just a function that's inside of, so to speak, an object or a struct. So more on these buzzwords over time. Polymorphism is a fancy way of saying that you can actually have hierarchy among your objects. So you can have, for instance, a human object, and then you can have a man object and a woman object that both share some common functionality or features, but themselves have disparate characteristics as well. And yet both man and woman are humans. So objects can behave in the same shared way, but you don't have to know in advance whether the object that you have in your array or your linked list or the like is one or the other. You can genericize it as this is an array or a linked list of human objects. And we'll see this more before long. Interfaces. So when I mentioned or picked on the dictionary implementation before, where we said you have to implement check and load and unload and the like, well, an interface is a way of saying my class, my struct, will provide you with all of this functionality. I don't know how I'm going to do it yet, but I commit to providing this functionality. So very often throughout the semester, what you'll probably do with your partner is sit down at a whiteboard, chalkboard, and decide between each other who's going to implement what functions or methods each of you is going to implement, what arguments those methods will take, what the return values will be. Then you'll go back to your respective computers or homes. You don't even need to see each other in theory for the rest of the period until you then to come back together and know that if you've at least implemented what you promised to implement, that code should be wireable together. Now, invariably, this is not going to work, right? So not certainly the first time. So more intercommunication will be necessary, but this is the idea, so that when you start to collaborate with folks, you're not going to both work on the same piece of the project. You're going to decide what lines you can draw and just make a commitment to one another to implement that functionality so that the other can depend on it. But what will happen quite often is you realize halfway into the week, halfway into the project, damn, that was not really the best design decision. So you're going to have to revamp your designs and your interfaces and what your code looks like so as to solve some problem that your partner or you didn't even realize that you were going to have until you tripped over it. We'll talk to you in the course about design patterns. So these are buzzwords that are often applied to techniques for writing code. The more you program, especially if you've only been in 50 or just one other course, you'll find yourself over the course of future semesters and even years that you're kind of writing the same kind of code a lot, and you find yourself perhaps solving the same problem again and again. So maybe even you, industrious as you might be, might write some helper file, a file containing all sorts of functions that you find yourself using quite a bit so that you can start reusing that same code. And so here too, we'll talk about common ways of writing code so that you can solve problems more generally, and not just for this problem, but you can reuse that code for other things. Singletons, factories, one of which I mentioned earlier, observers. These are just a few of the pieces of jargon we'll explore that aren't really fancy things unto themselves. In fact, you might have been writing code that adheres to these patterns already. You just didn't have a word for it, but these patterns typically allow you to expedite solving of problems that other folks have already had. So this is something, too, that will prove invaluable. Bureaucratic though it sounds, writing tests for your own code is hugely valuable, especially as your projects start to grow in size. I mean, even think back to the last CS course you took, whether 50 or 61 or something else, whereby you wrote your project and you think everything was working, you'd ran some tests, but then you went back maybe 5 minutes before the deadline, changed something, and then a whole bunch of things broke, and your code regressed to some earlier state where not much was actually working. Well, imagine a world in which before you actually resubmit that code, you run a command called test, and your code tells you yes, no, yes, no, yes, no, it does what you expect. So this too will become integral to the process of writing these projects for your own sake and your partners. And because as you start to write dozens and hundreds and even thousands of lines of code, if you make one change over here, testing manually the other 999 lines of code that you wrote to see if you broke something elsewhere is just not something you're going to want to do by hand. And so there's this great comfort you'll start to derive by writing tests for your code so that when you do change something, you don't even have to think about the rest of the code. You can run your test, and if it passes, you know you didn't break anything. Now that too is a bit of a lie, right? Because invariably you won't have tested everything you should be testing. But here too is an opportunity when your partner or when a classmate or when your TF does in fact find some bug or some fault, that's kind of a wake-up call like, damn, I should have caught that. But okay, not a problem. Write a